Well, welcome everyone to our fundamentals meeting, and I'm very pleased tonight to be able to introduce our speaker, Jim Sweitzer. So Jim is an astrophysicist. He has a long and distinguished career. He started his first job at the Adler Planetarium, and then moved on to the University of Chicago, and through that he got to go to Antarctica twice. And he has been involved with counseling on climate change and working with the American Astronomical Society on space debris and light pollution and radio noise. So trying to help protect.
Little louder, please. Little louder.
Okay, sorry.
Thank you.
So tonight, Jim is going to be talking about the planet Mars, very timely since Mars is going to be in opposition in just a couple weeks, and will be a nice object for our telescopes. And it'll be nice to hear from Jim and tell us a lot about this fascinating planet.
Thanks, Ron. If you can't hear me, just give me the sign and I'll get louder again too. Well, I'm really pleased to do this. Yeah, you can put the lights down if you like. I really enjoy this club, everything you've been doing and that I've been able to follow and participate in. I've enjoyed a lot. So it's a privilege for me to speak here. But I have to say that Mars, especially Mars in a telescope, is maybe not my zone. Okay, so I'll just freely confess that. And also, Mars, because it's such a fascinating planet and so timely in so many ways, all I have to do is pick up my phone and I see stories like this. Mars is alive. This was just a couple of days ago. I thought, oh God, the talk is already done. Mars has discovered life on Mars, only to realize that no, it's about geological life, that they found geological activity on Mars. So I'm sure you've seen that through the social media stories. Mars is near the top of the list with all kinds of strange things. I have been to Mars, however, in a way. Ron indicated that I've been to Antarctica. I was there 2 times. I worked on building the observatory at the pole, which is for cosmology, basically. It's about cosmic background radiation. But my thoughts upon arriving in Antarctica was this is the closest I'll ever get to another planet. It really is like being to another planet. And then on the left here, I've been on Arizona State University, and JPL ran a workshop on for anyone doing education with Mars using northern Arizona as a Mars analog. So I've been to the Mars analogs on Earth, if you will. So here's, again, the timing for this. I'm going to talk to Ron and all. We were thinking about ideas. Because of the Martian opposition, I just thought this is the time to talk about Mars. So I've divided this talk basically into 3 parts. The first part is just a little bit of the basics, and I'm sure a lot of people here, much more experienced Mars observers, will know a lot more about this than I do, but I'll just review a couple of those things. And then we'll take it up to about 1895 in the first part. The second part is where I use an exclamation point, and that's where Mars got really, really hot and interesting, pretty much from the time of Percival Lowell to just about the present. And then the last one, the question mark, I'm going to ask the question, can and should we go to Mars? Because that gets talked about quite a bit lately. So I wanted to, though, start with the person I think is one of the most important scientists to study Mars. This is, of course, Kepler. And around 1600, he, using Tycho Brahe's data, determined to be able to fit the orbit of Mars to a circle was impossible. He wound up having to fit it to an ellipse. That was a really, really big deal at the time because the Copernican system assumed everything was circular, and of course Ptolemy was circles on circles on circles. To go to an ellipse was really radical, and Kepler did that, and as a result, what fell out of this reconciliation with an ellipse were Kepler's laws of planetary motion, which actually get used for many other things now. This shows that the orbit of Mars is not a hugely elliptical, but it's elliptical enough to violate the circular motion thing. And of course, this helped Newton And the whole scientific revolution, I think, in part is based upon Kepler, his careful observing, or at least careful working the data out in the math to get elliptical orbits. So let's look at the basics, a little bit of Mars now. Here, this is Earth's orbit and Mars' orbit, about 50% farther on average from the Earth. So we have an opposition coming up on December 8th. And at that point, if you could draw a line between Mars, the Earth, and with the sun at our back, that's what opposition means, opposite the sun. It's not actually the closest. Technically, we get a little closer on December 1st. Through telescopes, those of you observe, and Ron has been observing this for most of his life, I think, you know that the size will change dramatically where we are. And at opposition, it's much larger than it is on average at other times. And so this December, it's I think about 18 arc seconds in diameter, which is a pretty good sized opposition. Now let's go back to now comparing it to other things we know. In reality, in size, Mars is approximately twice the diameter of the moon, but that's just if you could put them together, put them next to one another. In reality, even at this opposition, which is a pretty favorable one, it'll be about 1% the diameter of the moon. So that's like a small, very small crater. That's why seeing details are challenging with the planet. But this is a good opposition in any case. We see a show of hands. How many have already looked at it in the sky? At least, yeah. It's banging up there when it comes into view, and that's because it's in Taurus, right? So its declination is about as high a declination as you're going to get. So it's almost straight overhead. The next really good opposition will be in 2031, but the problem is it'll be, I think, in Libra or something like that, and so its declination will be minus 15, so it'll be about 40 degrees lower in the sky. So no matter what the weather is, this is the best one for quite a while, just if only because of the altitude in the sky. So let's rewind back and introduce telescopes. Okay, so the first real drawing done in a telescope that we know of was done by Huygens, again at the end of the 17th century. He drew, this is Syrtis Major. He was able to see this low albedo feature, which is a major feature people look for all the time now. Here's a picture, we found a picture of his objective lens. He refracted, was certainly not a doublet or anything like that, so it had to be stopped down. It was like a 63 millimeter, you know, a little about this big, and it had to be stopped down to 35 to avoid the aberrations, right? And it was an 11-foot telescope. This guy made real long telescopes, air telescopes, but even handling an 11-foot telescope at the time must have been quite a trick. So I'm always in awe of him and Galileo and others and what they were able to do with what they had. So let's go back to the 18th century, I'm sorry, the 17th century. So we're living in a Copernican world, the Copernican universe here to the right. It was a big deal. So now the planets are like the Earth, right? This is a big thing that Galileo pushed and so on. And the most popular, in fact, one of the most popular astronomy books ever was this one by de Fontenelle. It's the Conversations on the Plurality of the Worlds. This is the 1701 edition. I think this thing went through 8 editions. And this book, if anyone's ever read it, it's really, even now, a charming book to read. It's about an astronomer taking walks with a rich, wealthy lady in her garden talking about the planets. And one of the important things to realize that the mindset of people by the 1700s, because of Copernicus, we had a time when the plurality of worlds was really ascendant. And what that meant was all the planets were probably inhabited. They would have just assumed that. Okay? In fact, even the moon, the rings of Saturn, you name it. So why would God create these planets, put them out there in such grand display and not put people on them? So we have to realize this is a mindset going into certainly the 18th century and on into the 19th century, that the operative assumption is they've got to be inhabited out of necessity. So overall, the telescopes got much better, of course, by the 19th century. Here's Asaph Hall, the Naval Observatory. I think that's a 24-inch refractor. And I would conjecture that the big discoveries are all tech-driven. It's the same today. I was told a long time in graduate school that it didn't matter what the goals were for the Hubble Space Telescope. It's when it was launched, it was going to discover new things because it was such an advance in technology. So large refractors became tremendously important for Martian study. Infrared detectors, by just after World War II, the ability to examine it with the infrared, hugely important. Orbiting satellites in our lifetime that are able to arrive at Mars and go into orbit by the 1960s and 70s. Landers and rovers, we're in a time now where we've got robots running around the planet. And really the next thing to happen is we need to get some of that Martian stuff back here to Earth. We did have a meteorite come back to Earth. We've had several meteorites on Earth from Mars. We had one that caused a bit of a flap in the 90s. But this is sort of the progression here of these. So the outstanding observer really in the 19th century, one of the most outstanding ones that was Schiaparelli, Giovanni Schiaparelli. I think his family was basically Roman. They were pretty wealthy, all kinds of scholars and all. He actually had a niece who was Elsa Schiaparelli, the designer, designed really strange fashion designs. She was related to him. He had nothing to do with that, of course. He made his most important observations with an 8-inch refractor in Milan. Okay, and here are some of his drawings. These are drawings from one of his, let's see, the first one is like the late 1878, 1879. Then by 1883 and 84, made some really nice maps of Mars and started to really name. This is when the naming started to stick a little bit, and even much more detailed maps here by the 1880s. He used the Italian term canale, which means a channel in Italian. Doesn't necessarily mean something like the Panama Canal, but it means a channel nevertheless. And so he started to connect features with channels like that. So go forward another 10 years or so, and you had Percival Lowell, of course. I kind of think like a little bit of Elon Musk of his day. He was a rich kid from Boston who loved all kinds of things, just then fell into astronomy, built a beautiful observatory in Arizona and Flagstaff, and believed he had superior eyesight. And he started to take the canale idea even further. He was a marvelous writer. He wrote, you probably know some of this, he wrote travel logs of the East and in the Middle East, and he wrote a famous book called Mars in 1895. In it, it's actually a wonderfully written book. I've got a copy, but I didn't bring it. It's really worth reading just because of how well he writes and how romantic his notion of Mars is. Because he then draws gradually the conclusion that the periodic changes they saw on the surface of Mars, which we now know are probably dust storms and the seasonal changes, he translated them into Martians living on a dying world, moving water from the polar caps to more temperate latitudes on Mars. Okay, so the idea that there was some sort of intelligent life going on there really became ascendant. I've just recently been able to pick up one of these from the Lowell Observatory, had printed a Lowell globe with the canals. If you like, afterwards, come take a look at it. You can see how the mind just fills in the gaps admirably. Well, this was quite a stunning book. It was very popular, very nicely written. If I were a kid at the time, especially if an adult, I would have certainly fallen into its clutches. And of course, so did H.G. Wells. And so within a couple of years, motivated by Lowell's books, H.G. Wells wrote War of the Worlds. Okay, it was serialized at first, then went into book form. It is really quite good. I just recently read it. It's very scary. It's much scarier than I thought it would really be. So of course, we got these amazing observations. We got this waiting for Mars to come to opposition. We're still working with big refractors in people's drawings. There's a lot of controversy over Lowell's claims. I won't even begin to go through that. There's some nice books out recently on the history of Mars discovery. But in the popular mind, Mars got to be really popular, okay? It became fertile ground for science fiction of all types. Edgar Rice Burroughs, early 20th century, in fact, Kathy and I live right near his house where he lived in Oak Park. He wrote Tarzan and John Carter of Mars. By the 1930s, when the real pulp science fiction stuff began going quickly, Mars was a common subject. Okay. And by the 1940s, there's even Hal Clement. Not a big science fiction reader, but I do like Hal Clement. By the 1940s, he was writing about planets like this and dealing with these. And here was one of Hal Clement's favorite readers. Maybe you know who this guy is. From the 1940s, this is his high school pictures, Carl Sagan, okay, who was motivated by a lot of the science fiction that went on. And in my own case, I can confess to having collected all of these cards in the 1960s. And I had a complete collection. And how many have little brothers? I had a little brother who then, when I went away to college, he took those cards and sold them. So they're worth a lot of money now, the collection. But anyways, of course, Tim Burton made a movie. Curiously, though, Carl Sagan's thesis advisor, Carl went, of course, to the University of Chicago. Carl's thesis advisor was Gerard Kuiper, who turned out to be just tremendously important for all planetary astronomy, but in particular helped a lot with Mars. And one of the things that happened right after the war, Kuiper, who could speak or read a handful of European languages, was dispatched by the Defense Department to go to Germany to find out what they knew, some of the scientific research that went on. And one of the things he discovered was their use of, I think, Indian antimonide, or forget which one, the minerals, the metals, infrared detector that was being developed in Germany. I think someone in Northwestern worked on that as well. And by the late 40s, Kuiper was taking these infrared detectors, putting them on the telescope at McDonald Observatory in West Texas. So Kuiper really introduced the use of infrared, which is tremendously important. So here, for example, are 3 infrared spectra of Venus, Earth, and then Mars. And on Earth, you can see that there's an ozone line, and there's some hot water lines as well. But this big feature going through all of them is carbon dioxide. So by the time you could put infrared a spectrometer on a planet, you could actually measure its atmosphere, what its atmosphere is made out of. So at this point, by the 50s, we knew the Martian atmosphere was basically all carbon dioxide. There was no possibility of any sort of oxygen breathers there. So maybe life was plants, okay? So Martian life, at least the speculations by the scientists, got downgraded to maybe lichens, okay? So lichens participate in photosynthesis, and from what I understand about them, they are more like plants. The problem with, and then they found that on Earth, lichens are among the hardiest. They're like extremophile plants, if you will. And so they thought, well, it can withstand some of the real cold temperatures here on Earth. Maybe it can withstand some of the warmer temperatures on Mars. Remember, Mars average temperature is like minus 81 Fahrenheit. So the problem with this was it fails to what I would call the flawed astrobiology analogy. They find something here that might possibly exist on Mars, some condition there. They say, well, maybe life on Mars would be lichens. So there was a brief period where that was maybe considered. But the fact is, by the 1960s, we knew that any prospects of life on Mars were really challenged for a number of reasons. First of all, it's thin carbon dioxide atmosphere. The atmosphere there is a fraction of a percent of the pressure it is here on Earth, and it's CO2. It's extremely cold. There's no liquid water on the surface. We now know there is frozen water, but most of it's frozen beneath the surface currently. Mars has a polar tilt at 25 degrees, so it's seasons very similar to ours, but because our moon stabilizes the tilt of our planet, it keeps it around 23.5 plus or minus a couple of degrees. On Mars, the little moons of Mars don't stabilize it at all, so the Martian poles will shift by quite a bit, and have shifted, many times, 20 ice ages in the past few hundred million years. And so also with infrared astronomy, they could look for something called the red edge, which shows plants, it's photosynthesis of plants by absorption of red, and they did not see that. So it was really not a good time for life on Mars. In addition, we began to realize then by the 1960s that these incredible seasonal dust storms. I've got a little bit of, this is an analog to show you, I'm just passing it around. The dust on Mars, and there's a lot of it, would be, I think, 60 centimeters deep if you made it through around the whole planet. It's like talcum powder. So it's very, very, very fine dust. And especially in this time around, it won't be southern summer, but when it's southern summer on Mars, the temperature increases and it starts to cause planet-wide dust storms. So the real big changes then happen on the planet when we could actually visit it. All right. But Mars, as it turns out, it's a really hard place to stick a landing. Okay, so we had a real tough time dealing with Mars. In fact, here's a recent high-rise picture of Mars. In 2016, the ESA ExoMars, which actually was going to be called Schiaparelli when it got to the surface of Mars, it crashed into the planet. You can see the little dark spot. That's where the spacecraft landed. And just down a little ways, that box, you maybe can see the parachutes. So this is also an example of, this is a kilometer, it's that much, how the high-rise camera, in this case, can see very, very fine detail. So the Russians and the Soviets tried. They had 18 launches, a variety of orbiters, flybys, trying to do landers. They had 2 successes out of 18, so an average of about 10%. And we've done better, but still not perfect. It's 81% for American landings. Certainly for my lifetime, the first really important Martian flyby was Mariner 4 in 1965. And it basically went by, I think took about 100 pictures as it flew by. And it just happened to go over a lot of, I think, the southern highlands, so there's just lots of craters. And it looked a lot like the moon. And so it was a pretty depressing time for people who were hoping there was really interesting possibility for life on Mars. By the end of the decade, in 1971, Mariner 9 arrived, and things changed dramatically at that point. Now we had an orbiter, right, taking pictures, and a lot of those pictures revealed many, many interesting things, including water features that were actually cut on the surface by water. So the optimism about Mars, and that Mars might be an abode for life, at least at some point in time, the stock ticked up in 1971. Mariner 9 also showed this strong dichotomy. This is a map of the whole planet, like a Mercator projection, with the southern hemisphere basically cratered and ancient, and the northern hemisphere having been resurfaced somehow. Okay, so the idea that came up at that point that maybe there had been water in the northern hemisphere that cleaned off these craters, the ancient craters. Because the craters are basically like the craters on our moon, came about at the same time of the heavy bombardment, just a billion years or so into the life of the planet. So by 1972, the Martian stock went up tremendously, and the funding started to go up quickly. Carl Sagan and Berenson, who was at Boston University at the time, ran a workshop called Life Beyond Earth and the Mind of Man. Philip Morrison was there. This is George Wald. They all began to speculate. It sort of went through in a sense, like the Drake equation, starting to speculate and go further and further with Mars, thinking that Mars was a place where we had idea that we could see that there had been water in the past, and so on. In fact, this conference, if you've seen it, was made into a NASA film, and the host of the film was this guy, Orson Welles. And it's so, I hate to say it, kind of biased to put him on. He qualifies himself and all, but the weight of Orson Welles and his, of course, infamous background with the 1939 broadcast of War of the Worlds sort of dragged this down. But the benefit was that this allowed enough funding. NASA had other things on its mind in 1970. They got enough funding to go to get the Vikings funded, which were a very, very expensive mission, even by today's standards. So by 1976, we landed 2 spacecraft actually on the planet for the first time, and they dug around up in the northern highlands. They discovered some sort of chemical activity. There was some debate as to whether it could be due to organic life, but they realized it was just that the soils were very active chemically. So really, not much happened after this. This was a big deal, and there were some other Mars missions afterwards, but I think they thought the book was sort of closed at that time. But in the late, 1984, this meteorite, is about as big as one of these globes up here, was discovered in the Allen Hills of Antarctica, which is good at collecting meteorites. And by the study of the gases in the meteorite and so on, they realized that it was that it actually had come from Mars. McKay was the scientist. When they did micro photography, they started to see strange little structures. They thought, well, maybe there's life. This rock is 4.5 to 5 billion years old. They were able to date it, and it went through quite an adventure. I know that this was around the time. This is August of '96. I had just moved to New York City, and the American Museum of Natural History, who I worked for at the time, had just gotten a $5 million grant from NASA to build the Rose Center for Earth and Space. Okay, so NASA was not happy about that because it was an earmark. This is a story I've been told to a lot of people. So they called us, which meant Ellen Futter, who was the head of the museum, Neil Tyson, and I, to the principal's office. This was the principal at the time, Dan Golden. And we actually were in his office the day before this was announced. He was pretty nervous about that, but he got kind of mad that the American Museum had used an earmark to pull money out of NASA. When he found out that Neil was from the Bronx, as he was from the Bronx, they kind of softened up a little bit. So this was the late 90s. Bill Clinton actually did a press conference announcing that NASA might have discovered life on Mars. So it was a big time, again, for life on Mars. As it turns out, it only took this claim was so extraordinary, you'd have to read the papers. There's so many parts of the moving parts to this, and so many people went after it that it only took a couple of years before they showed that this was not an evidence of life at all. Nevertheless, Dan Golden at the time was able to make astrobiology a major mission, if you will, of NASA. So it got put into the NASA mission. And that then started to get the funding for the robots and rovers, orbiters in particular, that came afterwards. This is the Mars Global Surveyor on the left. This is Odyssey up here, and this is the Mars Reconnaissance Orbiter. The two on the right are still going. and going relatively strong. The one on the top is Themis, an infrared camera, which is able to do mineralogy, and the Mars Reconnaissance Orbiter is able to, it can observe down to 10 centimeter resolution on the surface of the planet. So they're still doing extremely well. They also serve as communication links back to Earth. These paved the way, or these helped all pave the way for being able to put landers down on the planet again. I want to show, I think, what I consider one of the most extraordinary things is what we're able to do with these landers. And so I have the animation we'll go through of just landing the recent one, Perseverance. So again, this, I've been told I have to make sure and say it's an animation because it's so good. And I show this to people. But the problem with Mars is you're coming from such an incredible distance, incredible speed, and the atmosphere there is 1% the thickness of ours, so it's not easy to slow down and actually stick the landing. So when it gets close, it dumped the back shield. Just enough that you have to really pay attention, but not enough to really help you as much as you love. Perseverance rover is about the size of a parachute slows it up. So if you're planning to go visit, this is what your ride is going to be like. Whether you're a robot or a human, it's going to be something like this, I think. Have nuclear power, so they don't have to rely upon solar power, at least the current rovers. There's a movie out. Has anybody seen the movie? Yeah, about Odyssey with the older rovers. Anyway, so that's it. Here's some pictures of the rovers. This one is Sojourner, one of the ones that came down in airbags. These other guys on the left, and then this is Odyssey. It's the one that has the movie. He's out in the movie, and then finally Perseverance over here on the right. These things are amazing. They're just little roving laboratories, if you will. Perseverance is going around collecting and caching samples to return back to the Earth as well. And the big motivation for these two, these have basically gone to places that are convenient for them, but we also had landers that don't rove. Phoenix is one that went to look for water, evidence of water beneath the surface, and it did do that. On the left is a picture of Mars as it was maybe in its, about 1 billion years into its existence, when it may have had this ocean. It had an atmosphere thick enough that liquid water could survive on the surface of the planet. Down here in the lower right is a picture, I think, from it's from high rise again, showing some sort of like salt deposits, so that water does seem to seep out if it gets warm enough at times now. But basically, the water's been gone, practically speaking, for a very long time. So I know that when the astrobiologists talk, they always talk about follow the water. And I'll just compare water on Earth and Mars, at least what we know. Now, we do believe we have evidence for liquid water on Mars back around 4 billion, 4.1 to 3.7 billion years or so ago. But on Earth, it's been around all that time. These are the sorts of things that have been happening biologically on Earth since then. The first bacteria, the photosynthesis, the oxygenation, bring oxygen in our atmosphere, first cellular, first cells would be eukaryotes that had nuclei. Our ozone layer finally formed around 600 million years ago, and then shortly thereafter, the Cambrian explosion when multicellular animals like us came about. On Mars, basically, we don't know anything about life, but we know that Mars lost its magnetosphere, its magnetic fields about a billion and a half years ago. And those are really critical too because they provide the magnetic shielding against cosmic rays, right? So on our Earth, our atmosphere helps, but so does our magnetic fields. So where are we now? A bit with some of these rovers. On the left is the Jezero crater region. This is a crater on Mars where there's a fan delta. Clearly water, we think it's water, has flowed into there, and then there's this nice little crater in it, so that helps excavate down to it. And on the right are pictures from the current rover there showing the rocks, and then this is a close-up down here. But last summer, Science Magazine, this is September, autumn actually, the first results are showing these rocks are igneous rocks. They were not sedimentary, like they thought there'd be more sedimentary rocks. We find they're igneous. It's not that there aren't water minerals that would thrive in water in the igneous rocks. Basically, it's more igneous rocks. So anyways, the stock a bit for Martian life has gone down just a little bit again. So what are the prospects for Martian life today? Here's the challenges to it. If it's there, it must be below the ground level because the ultraviolet on the surface would kill anything that we know pretty much, and the cosmic rays make life difficult there. There's recently been a story about this Deinococcus radiodurans, or Kunan, the bacterium. I think it's someone from Northwestern, I don't know. I'm from USC, so my judgment of Northwestern is off a little. But this bacteria can withstand radiation here on Earth. It's a pretty hardy thing. So now this is saying, well, we've got this bacteria here, maybe there's such a thing could exist on Mars. The problem is, this is a pretty evolved organism in any case. And I think it falls again, just like the lichens did, to what I call the flawed astrobiology analogy. And sure, we can find something here that can take those kinds of cosmic rays, but you have to consider all the past it's gone through as well. It's not much of a life in any case. I worked on a project to bring black smokers up from the Pacific, the Wanda Fuca Ridge, and we had it's on display at the American Museum. We had Emery Friedman, who was a researcher in extremophiles, especially in Antarctica. And in the 80s and 90s, in the early parts of this century, extremophiles have been really popular and interesting and used as rationale for life on other places. And Emery talked a lot to us about the extremophiles he knew in Antarctica. He said, well, they can exist there in the dry valleys, but it's not much of a life. So anyway, the next big thing coming up is to get some of these Mars samples back. And there's a set of missions now getting put together underway. I'm not sure they're fully funded, but ESA will be working with NASA to take, I think, Perseverance will cache maybe a dozen or 14 samples. In the Jezero crater area, there will be another rover. We'll go back and pick them up, and then take it to a craft with a little rocket to send it back into Martian orbit, or a rendezvous, and then be shuttled back to Earth. And I think they're now looking to find a laboratory on Earth to deal with these samples as they come back. It'll be in Houston probably. So this is the latest, and I think the big deal here is getting some of these samples back. We can do a lot with these rovers there. We can do a lot more if we can get some of the samples back. So the final question I wanted to just touch on here is, are we going to Mars anytime soon? Is this a place to take a vacation? Okay, so let's put our hat on a little bit about what it would be like for humans to go. Okay, just take a minute on this. First of all, here's a typical mission profile. The problem is that you can't just directly go to Mars. You have to wait until the timing is right for the launch, and the shortest trip there is, in this case, typically 224 days, 2/3 of a year, just to get yourself to the Martian planet. Then you have to wait. It's like you have to go to the bus stop and wait for the buses, the next round of buses to bring you back, to be able to get you back to Earth on a short path. So you have to wait well over a year, 458 days. Then you got another 2/3 of a year to return trip. So the total is about 919 days through the math. It's just short of 3 years. So it's a very long, it's not like Neil Armstrong and Buzz going to the moon, a few days here, a few days back. So it's a much bigger challenge. The costs, there really isn't a budget for this period. I've been looking at the budgets. We're not funded. You have to be funded near the funding levels of the Apollo program to do something like this. And right now, if you do the ratio of some of the estimates, this may be a little bit on the high side of the cost of mounting human NASA-mounted missions with astronauts to Mars compared to the cost of this rovers program, which gets launched every couple of years. It's about a factor of 80. So it's much higher than the cost of the robotic missions. So we just had so I'm going to talk a little bit here about the challenges, especially for humans on Mars. The InSight lander, which is the one that just finished its mission on Mars, it was a seismograph and also had temperature probes of the surface. It was not a rover. It had to stop because of the dust. Its solar panels got covered with dust, so it can't get power. They were hoping for a storm to blow the dust off, but it didn't happen. So the dust is a huge issue, of course, on Mars. It would be a huge issue for any astronauts. In part because the dust contains, these are perchlorate salts with calcium. These are toxic. The percentage there is high enough that it will be toxic to us and toxic to plants. So this has to be dealt with. You just can't bring your clothes inside and dump your spacesuit outside. Any plans I've seen, the spacesuit has to be left outside of the spacecraft. So dust. There are other challenges for humans aside from the long trip. We don't know what it's like to send people on such a long trip to a place where the gravity is 1/3 or so of ours and bring them back. We know what it's like to have astronauts in orbit just a couple hundred miles above, but even the astronauts who've done that wonder what is it like when you're now 100 million miles away. The gravity is low, so you get there, when you come back, it's going to be really tough too. It's extremely cold, 100 and some degrees on average, colder than it is here. The atmospheric pressure is low, so you're always going to have to be in a suit if you go outside with no protection from cosmic rays. And then the last one is one, as my colleague said to me, he says, what about the food? There's just no good restaurants. This is like the field of Mars, right, in French. They just don't have this. You have to take your food. It's not like Matt Damon growing potatoes or something. I never thought that, but you have to bring your own food. There's another issue there. It's embodied in this number, 24, and this is, I think, would be really important for people there. This is the conversational beat time in minutes. If I send you a text, I'm going to have to wait for 24 minutes until I hear back from you. Now, my brother usually takes me 3 or 4 days. It wouldn't be different for me communicating with my brother. He rarely answers his texts on time. But for people who want to have any sort of meaningful connection with my wife or something, 24 minutes isn't going to do it. So there's just that time delay. Anyway, so that's a little bit of the NASA perspective, I think, on this. But there are private carriers, too, who go SpaceX, right? I'm sure you've heard of this. I think this is their big rocket, what do they call it? Spaceship One or something. And I think they're supposed to launch relatively soon. I think Artemis is hoping to launch tonight. This is Mr. Musk's version. He's claiming it will only cost $100,000 to $500,000. That's one way. I don't know if that's like coach and then business class. I haven't seen any plans from the inside. He hopes, he says we could have 1 million people. The goal is to have 1 million people settling Mars. So, anyways, I wouldn't gamble on this guy. I don't think anybody has lately, but so that's this sort of plan. And I think finally my big point to this group, but also more likely when I talk to younger people, is we're really already there. Just if we can accept the fact that robots are our proxies, we've already been there, and we're doing a really good job. The Mars Reconnaissance Orbiter, if you can read this, just as of a few days ago, it's been there 16 years, 8 months and a day. It's already accumulated like 437 terabytes of data. And so we have a lot of really wonderful information. I've not seen Mars well in a telescope, I'll admit, but I've spent a fair amount of time. I had a class in astrobiology, and as our laboratory worked, we just observed Mars. But using tools like JMars. Has anybody ever used JMars? I really recommend it. You've paid for it. We've all paid for it. This is, means for Java Mars. It's available. It's a browser window that allows you to pull in Martian databases, other planets as well, and use them. And you could actually do research with them. This is it's managed out of Arizona State University. Absolutely, especially if you teach anything, you work with younger people. There's ASU has a whole curriculum that goes with this for like about a 28-hour immersion. I've used it with high school students, but I've also used it with college students. But I've also fiddled with it personally. It's just great. You can pull data from Mars, especially from the Themis mission, because that was managed at Arizona State. The HiRISE is on the Mars Reconnaissance Orbiter. So I think you can access HiRISE data through JMars, but you can also get it straight through the HiRISE thing. And this HiRISE data is fabulous. This stuff is down to 10 centimeters. We have better imaging. You know, when you see those movies where they tell that they're chasing some spies, put the camera down and look at their license plates, and we can do that on Mars. Not as easy here on the Earth because of the atmosphere, but we could do that on Mars. This spacecraft can do it. And so this is the website for it. It's University of Arizona, highrise.org. They manage the HiRISE camera. They have also some of the images are smaller, can go through JMars, you can look at them, but they have some really large images that you can use. They have an application called HiView, which allows you to look at gigabyte images really well. So this is another one I really recommend because we've paid for it. It all belongs to us. We can look at this stuff, and it continues to be used to this day. They'll go back and look at things. They haven't by any means mapped the entire planet. I even think the University of Arizona people have a program where you can recommend, and they especially encourage amateurs and others studying the planet to recommend locations to image. Anyways, I just want to end by, you don't even need all this tech either. You don't even need a nice telescope like I know a lot of you guys have. There's going to be an occultation by the moon coming up, I think on the 7th. If it's clear around 9:10 p.m. here. I think this is accurate. So by all means, go out and look at that, and you don't need a telescope. Binoculars would be beautiful for that. Anyway, so thank you very much. I hope this was of some interest to you or something new that you didn't know about before. Just want to thank everybody here for having me. Comments or questions?
So I have one question. You said you were at like analogs of Mars when you were in Antarctica,
Yes.
Arizona.
Right.
So based on your experience, what do you think if you were to travel to Mars, what do you think it would be like to experience that compared to what you did in Antarctica?
The Arizona analogs were about the geology. Okay, so the geology of they have red rocks that look just like the ones we expected to see at Jezero Crater up in the volcanic rocks in the Flagstaff area. So that was all about that and just understanding how they go about studying them. With Antarctica, it had more to do with human missions. Okay, more about how the humans at Amundsen Scott South Pole Base behave, especially over the winter. I was not, winters for graduate students and postdocs. I was not in that category, okay? And so there was, NASA had someone they call, I think it's the NSF, but I think they did it in conjunction with NASA. They had an anthropologist we called the monkey doctor. They studied everything about human behavior in this kind of environment. And so you would be interviewed. I never stayed there for long. The people who stayed there for a long time, they studied how people broke into groups. There was a group that hung out in the galley and a group that hung out in the bar. They looked for rivalries. They found that women tended to mollify things and keep people from fighting. And so all that stuff, I know they took those data from Antarctica. They have, of course, NASA tried on Mauna Kea or Mauna Loa, one of those Hawaiian volcanoes. They put a small base. So understanding how people behave in close quarters for a very long period of time is really important. Yes?
When Mars did have liquid water on the surface, was it marginally habitable, like the temperatures and atmospheric pressure weren't
It had to be.
too much?
It couldn't have
from
been
what they
that.
are now?
Right, it had to be above freezing. It had to be pressure enough to keep the water from evaporating. So, yes, so maybe for 100 million years or something, it was more hospitable. I probably still would have been cold, maybe like Norway or Scotland, I don't know, but nevertheless, maybe hospitable. So the big question is, would that have been enough time for any sort of life, type of origin of life we know about to take hold? We really don't know, and we don't have any evidence yet. People study that. I think the University of Chicago just hired a top beginning of life biologist to look at that sort of thing. They did the Harold Urey, the Miller-Urey experiment was done at UFC right in the 50s. And Stanley Miller, was he the advisor? One of them was the senior, I think it was Miller, was also on Carl Sagan's thesis committee and really gave Sagan a hard time. Sagan was really the first exobiologist who really was focused on it. Just had an enormous impact. But in the 1950s and 60s, he encountered lots more skepticism than he did at the end of his life. Yeah.
So the perchloroates? I can't remember.
Perchlorates.
Yeah, that one. Do we have anywhere here on Earth that is relatively similar, right?
I think they're used, I'm not a chemist, so there probably is a chemist in the audience here doing this club. I think they're used for disinfectants, so they exist here as well. I think it has to do with the concentration level. So it's just on Mars, I don't know, I didn't write the number down, but the concentration level is high enough on Mars that you just would have to deal with it. Yeah.
Just curious, on your final acknowledgement there, is the additional letter an intentional commentary or one of those Freudian things? I mean, that's what I think
was
of it,
intentional.
but
It was
a lot of
intentional.
people don't.
There's no SpaceX. I've got a lot, I've got reasons, axes to grind with that guy. Go ahead.
So
I
with
do.
the
Yeah.
with the Artemis launching tonight, right? And the whole goal of building a moon base of some sort. Do you think that will shorten that time frame as much as they're really hoping that it will be able to? Because that 923 days is really steep.
Yes.
And I don't see
The moon is-
100% how it's going to help, really.
Well, I think, yeah, I'm really on the robot team, okay? But I see the value of learning how people to work and be in space. I'm not against that. I think that going back to the moon is a real step along the path because there's so much they can learn just in our backyard rather than going, partway across the inner solar system. So there's a lot they can learn there, and it is on the path to going there. There's talk of having an orbital base around the moon. I forgot the name of that, where you don't have to actually, where you can assemble a larger spacecraft for the actual journey to Mars. So that's all part of that program. The problem is, and I just grabbed the numbers, is that even with Artemis is about $7 billion a year. These Perseverance rover is about 2.9 billion total over its lifetime. So Artemis is actually not that much more. A double is not that much more. I think you'd have to go to about 150 billion a year to mount a real significant Mars mission. And I may be a little pessimistic, but the one number I pulled up was 1.5 trillion for the Mars mission. Now, I do criticize Musk for a bunch of things. I do like his cars, but he's surprised us. I mean, those rockets he's got perform very well and are pretty amazing. So there is something to be said for that. But I don't know. Artemis is certainly a step along that direction. I hope they pull it off. It's kind of exciting to hear about and see.
Well, I guess, what about the landing part? I'm still thinking about the 82% success rate, and that's with the sky crane now.
Yeah.
And the SUV, if we have people going down,
Right.
it's going to be bigger. Maybe the 100,000 for Elon is the Russian ones where they're only 10% successful. You pay more for the 82%. I don't know.
I don't know. It's a really good point, and I think I'm really impressed with the success rate of the rovers recently, and a lot of the NASA missions, or the Webb telescope, which is one of my favorite projects. It's just I've known people who spent their career working on that, and they send this thing off and they unfold it, a million miles away. So NASA's engineering now is really good, but it's extremely risk averse. Okay, that's why they delay so many times. And it's even more risk averse when there's humans involved. So my guess is that if and when funded and they want to do it, with the current mindsets, they probably would be successful because they wouldn't put the astronauts in harm's way. I've heard plans to just take them there and have them orbit and then come back. So, but unless we have a lot more funding, it's not going to happen that much.
So is the sample return mission the only current one on the drawing board or whatever?
I'm not sure. I think the cadence of the JPL type missions is every couple of years they try to launch something now. And so I think there are probably other rovers, but most of the treasure now is going into getting the sample return thing going. And they have to find a laboratory, they have to make a laboratory, it has to be safe place to have the bugs so that we don't have an H.G. Wells adventure taking off in Texas. And if that's where they go, and that requires a lot of cooperation with ESA. So there's a lot going on that one right Cool. Well, thanks so much for having me. My only request of you is, because I know a lot of you guys have better scopes, better access to scopes, so people get good pictures of Mars, post them on the club's site. I want to see them.